Hi everybody. So in this video we're going to look at how we can differentiate functions involving e to the power of x. And before we start with example 1, I want to show you what's special about differentiating e to the power of x. And we're going to use Desmos. So we've got two curves. The red curve is a function of a to the power of x, where a is just a constant. In this specific example it's 1.25. And the green curve is a gradient function. And you can see at this point, when a is 1.25, the function and its gradient are two entirely separate things. But you can see that as we increase the value of a, as a approaches 2.58, or even closer, 2.7, the function a to the x becomes identical to its gradient function. And this is a very special property, where the derivative of a function is equal to that same function. And this happens when you're raising approximately 2.7 to the power of x. And because this is such a special property, we call this a natural number. If we go back to our lesson, the actual value of that constant was 2.718, and we call this the constant e. So the property is, when we have y equal to e to the x, the gradient function dy by dx is exactly the same, e to the x. And this is really useful in all kinds of areas of maths. In this video, I'm going to show you how we can differentiate exponentials using this property. Okay, so for example A, if we say that y is equal to e to the 2x, and we've been asked to differentiate this with respect to x, the first thing we need to understand is that e to the 2x does not share the same property. It has to be e to the x, or e to a single variable. But what we can do, we can introduce a third variable, let's say t, and we call this 2x. Now we have y equals e to the t. And at this point, we can use this property, where dy by dt will be e to the t. The problem we have is, we wanted to work out dy by dx. We wanted to differentiate it with respect to x, not with respect to t. So we're trying to find dy by dx, and what we have is dy by dt. But if we multiply this by dt by dx, you can see that this dt will cancel with this one. So what we're left with is dy by dx. So now we need to multiply dy by dt by dt by dx, and we can work this out quite easily by differentiating this with respect to x. So dt by dx will simply be equal to 2. Now we can substitute each of these into our equation, and this will be e to the t multiplied by 2. And in terms of x, we know that t is 2x. So we'll substitute this back into here. So dy by dx will be e to the t multiplied by 2, or 2e to the 2x. And this is called applying the chain rule, when this is our chain. And it works because these two dt's cancel to give us the dy by dx. Let's apply the same idea for question B. So if we say that y is equal to e to the negative 1/4 x, then we can let t equal this power, so negative 1/4 times x. And then we'll substitute this t into here. And now we can find dy by dt as e to the t. To work out dy by dx, we need to multiply this by dt by dx, which we can find by differentiating t. So dt by dx, negative 1/4. So now we can substitute this and this into here. So dy by dx will be dy by dt multiplied by -1/4. We can substitute this back into a t, so we get -1/4 multiplied by e to the power of -1/4 x. Okay, so do you want to try and differentiate question C? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So if we replace this 3x with t, then we can work out dy by dt as 2e to the t, where t is equal to 3x. We'll work out dt by dx, which is 3. So dy by dx will be 2e to the t multiplied by the 3. We'll write the t in terms of x, and the 2 times the 3 will give us 6. So we get 6 times e to the power of 3x. Okay? Let's try some more questions. Okay, so for example 2, we've been given this equation for y, and we've been asked to work out dy by dx. So the first thing we're going to do is we're going to expand this bracket. We can apply the power rule here, so we get e to the 2x. So for dy by dx, well, this would just be the same, and then we need to apply the chain rule to differentiate e to the 2x. So if we say that w is equal to e to the t, where t equals 2x, then dw by dt will be e to the t multiplied by the derivative of this, which is 2. We'll substitute this back into here. So this will give us 2e to the 2x, which I'll put back into here. And this is our derivative dy by dx, okay? So perhaps you want to try question B. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So the first thing I'm going to do is I'm going to split up this fraction. So by splitting up this fraction, I can work out each of these separately. We'll apply the division rule of indices here. So we get 3e to the minus 2x. And from this one, we'll get the negative x minus the 2x. So negative 3x is our power. And now we can work out dy by dx. We'll apply the chain rule to each of these, which we can do in our heads. We'll differentiate this inner function. We'll get -2. We'll multiply that by positive 3. So we'll get -6 e to the -2x. We'll differentiate this inner function, and we get -3, which we'll multiply by this 2. We get another -6 e to the minus 3x. And then we can factor out this -6. This will give us e to the -2x plus e to the -3x. And this will be our solution. Okay. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.